Hello, my name is Sarah, and I'm going to talk through the new explicit shoulder slip ring feature added in Oasys Primer version 20. The seatbelt fitting tool is used in Primer to fit one or more belts to a structure. In brief, the process requires defining the structure entities to which the belt will be fitted, defining the basic path of the belt with the desired properties, fitting the belt to the structure, and meshing the final belt shape. A typical three-point automotive seatbelt will have a D-ring near the shoulder area and a buckle near the pelvis area that affects the shape of the belt. These slip rings can be modeled in Primer in three different ways, either by using the element seatbelt slip ring LS-DYNA keyword, a radius meshed slip ring, or an explicitly meshed slip ring. The latter option is the most realistic method for modeling slip rings in Primer and thus results in the most realistic belt shape. However, when using the explicitly meshed slip ring method, it can be a bit tricky and time-consuming to define the basic belt path through the slip ring slot. It can also be hard to predict the natural position of the slip ring, which previously required adjusting the position after an initial fitting and repeating the fitting with the new position. This process might have to be repeated multiple times for optimal results. In version 20, two new solutions were added to tackle these issues for the shoulder slip ring. The first solution allows to automatically adjust the basic belt path within the slot of the slip ring. The second solution allows to automatically pull the explicitly meshed slip ring into its correct position during the fitting process. I will now talk through the steps required to apply these solutions by means of a short demonstration. The seatbelt tool can be invoked from the safety menu. First, you need to define the structure to which the belt will be fitted. All parts expected to be in contact with the belt have been added in the simplified model. Note that the shoulder slipping part is included in the definition, given that I have decided to use the explicitly meshed method for the shoulder slipping. Next, you need to define the basic path points. In the interest of time, I will proceed using a model with a predefined path. Note how I didn't need to position the path within the slot of the shoulder slip ring, but simply created a point near the bolt, as this will automatically be handled later on. Then you need to go to the explicit slip ring edit panel. Before setting any value, make sure that you're facing the side of the slip ring where the penetrating belt section is connected to the first end point, just as shown in the sketch. Then you need to select the part set forming the shoulder slip ring, a node at the pivot center, as well as two nodes at the left and right lower corners of the slot. The rotation axis can be defined either as a vector in the global coordinate system or by using two nodes. I will choose the vector option. In both cases, the vector should be pointing outwards from the screen. The Adjust button can be used to modify the basic path to position it within the slot by replacing the point nearest to the slip ring by two new points. If a point projection was set as part of the fitting parameters, the new belt path might slightly penetrate within the slip ring upper section. This can be corrected through the Advanced Path Definition settings by slightly dragging the blue handles. You can also make any other desired adjustments. If you are not satisfied with the result, you can use the Undo button to restore the initial path point. Otherwise, you need to accept the new configuration. Finally, turning on the Rotate Slip during fitting tick box will dynamically adjust the position of the slip ring when the fitting runs. Note how the number of iterations fitting parameter automatically changes to the recommended value of 3. However, setting this property to a low value affects the speed of the fitting process. Therefore, it is recommended to turn this on only when the slip ring is required to be pulled. So I will turn this off and run the fitting. Once the belt seems to start dragging towards either of the slot sides, turn this option on and resume the fitting. You can observe how the slip ring gets rotated around the pivot center so that the belt is balanced out in the slot. When the slip ring starts to stabilize in its correct position, you can turn this option off and resume the fitting again. You can repeat the process as many times as necessary. As you can see, the slip ring was pulled into its natural position, and the belt path was successfully fitted to the structure. Finally, you can accept the fitted shape and apply the meshing. All necessary information to define the explicit slip ring gets saved at file scope as part of the belt definition in the belt slip ring card. This solution supports slip rings formed of both shell or solid elements. However, avoid using a mixture of shells and solids as part of the structure definition for the slip ring. Additionally, to avoid penetration issues with the upper section of the slip ring after using the Adjust button, you can select only the lower section of the slip ring as part of the structure definition instead of the whole slip ring. And finally, all belt sections in contact with the slip ring must have the same element length when the option to automatically pull the slip ring during the fitting is turned on. This is automatically handled if the Adjust feature was used prior to the fitting. Thank you.